In a preceding video I have talked about the op-amp and how you can use it as a switch, say when the reference voltage set by one of the potentiometers is met by another voltage, the op-amp switches. But this video is all about sensors. Perhaps it's interesting to tell something about sensors. And I have a special box. This is that box. And here are all, say, the sensors that I have and the sensors with which I do experiments and with which I want to do experiments. There are a lot, and of course all these experiments take a lot of time. When does the sensor switch on a relay or whatever, or a transistor? How does it switch on, say, in terms of voltage and current, etc., etc. How to make a sensor switch to a certain temperature, when the temperature gets high or when the temperature gets low, too low, say the under temperature and the highest temperature, etc., etc. A lot of experiments to do, but now I only want to focus not only on this circuit, the op-amp, and the relay that has to switch, but on the properties of the sensors. Well, I have to pen over, of course, there are a lot of sensors. These are, for instance, light sensitive sensors. This is more or less the classical solar panel circuit. You can use it as a sensor. So don't throw them away in the garbage. Take them out of, say, cheap Chinese garden lamps. Use them as sensors to make, for instance, a light dependent switch. Here are two other sensors, all classical light sensitive sensors. And when I talk about light, I mean the visible light. There's also, say, the invisible light, say the ultraviolet light. And here you see, for instance, ultraviolet light sensors. This is a typical peer sensor. You can find more information on the World Wide Web. And these are two sensors out of discarded laboratory equipment. And they were specially made for the ultraviolet light spectrum. When you want to know more about it, go to the World Wide Web, see what that means, and where, say, the highest ultraviolet frequency, say, light is, and the lowest, and etc., etc. But these are these typical sensors. This is the peer sensor that's often used in all kinds of, say, safety circuits. Say, when a warm body gets into the distance of that sensor changes its resistance, making something switch on or off. Well, of course, when we talk about light sensors, the intensity of the light spectrum also plays a very important role. Here a few out of old Chinese solar lamps. Other sensors are, for instance, the temperature sensors. I've made a video about that. the temperature bus, and I used in that case a germanium transistor, but you can also use a germanium diode. And these are, say, the values that I found out, tested in a room temperature. It is 2 mega ohm, say the barrier voltage of a germanium diode, and when the germanium diode gets hot it is 50,000 ohms. So an enormous variation in resistance that surely can make such an op-amp work, making it to switch on its output. Talking about the frequency of sensors, infrared sensors, I've talked about it. This is an infrared light diode. The frequency is in the nano range. You can surely find all these spectral information about where such an infrared diode is on its most sensitive point in the datasheets, or the datasheet when you know a type number on the World Wide Web. Say this is a kind of electromagnetic sensor. It's the classical so-called reed relay. Its working is very simple. There is a coil, you can see it here. There is a glass envelope here with 2 contacts, and when you say send DC through that coil, the contacts make contact due to the magnetic properties of the contacts. So activate it when a current is flowing through the coil, and here you see an experiment that I did. This is the activating coil. The reed relay is inside, and the good thing of the reed relay is that it is say enveloped in a glass, and completely free in general of moisture and other influences, so it can switch for a very, very long time without getting corroded. Of course, when the current is too high, you can also get say corrosion on the reed relay contacts, but anyway, when the current is not so high, such a reed relay can last more or less forever. And here you see, say, the big one, how such a reed relay looks like here. This is, by the way, a big one. It also needs, say, a big coil to be activated. Temperature sensitive resistor. You can buy them everywhere on the World Wide Web, on electronics websites, etc., etc. They all have different properties. Of course, very interesting when the say the temperature goes up or down, the resistance changes, and that can again make such an op-amp switch on or off. Though I have to say that the Schmidt trigger, like I told earlier, is the best circuit to use such a temperature sensitive resistor. Just like the diode here, this is also a temperature sensitive resistor. Perhaps this also, I have to test that, etc., etc. Well, here we have the classical photodiode. On one side a light emitting diode, on the other side a transistor with an open base, and that open base means that it is sensitive for light. I don't know, say, the frequency of the light, to which this thing is sensitive, but anyway, it's only an example. And this is a temperature dependent resistor or an IR, infrared sensor. And here many infrared sensors. They were used in computer mouse. They are even now 2023 used in all kinds of applications. Say there is a kind of slit here, and in that slit say a circle goes on and on. In that circle there are holes. Say it's a kind of gear, and that also means that the light is, say, blocked during a certain piece of time, and that means that you can derive a signal out of such a infrared sensor. Often these are infrared sensors because they must not be affected by, say, normal light, and then I mean light in the visible spectrum. This sensor works with light in the not visible spectrum. Though, say, light in the visible spectrum can have an effect on the sensor, and that's a reason why, for instance, in a computer mouse it's completely dark. So when this gear moves, signals are sent to the computer, etc, etc. So in general no light may enter, but sometimes in some cases, and you have to search that out for your, say, specific application, to which light band, frequency band such a sensor is sensitive. When it's also sensitive for visible light, don't use it, say, in normal daylight applications, etc, etc. I did a lot of experiments with this sensor. It worked very good, and it was, say, simply a infrared sensor, and I could, say, drive the diode via a 1K resistor to 12 volts. So that means that the diode lights up. So this is the diode here, it lights up, and here is a sensor, and that sensor was connected in that case to the base of an NPN transistor, and that means that the light, the infrared light, activates the transistor. You can also use a Schmidt trigger for that purpose. That was more or less all to tell. Thanks for watching. Pen over somewhat. Hope it was not too sloppy. And when I have time and inspiration, I want to show a certain circuit with where one of these sensors is used. And there are a few circuits on my YouTube channel where I've used sensors, light emitting sensors, but not in combination with an op-amp, only with, say, a Darlington or a very simple other 2 transistor circuit. And when I have time, I will give the links in the text box.